Onboard Diagnostics refers to a computer's ability to analyze the operation of its systems and output data showing any problems. All new cars and light trucks now have this self-test feature. It is critical that you know how to use this technology to keep the vehicle running properly. This video will explain the general capabilities of the onboard diagnostic systems. Late model OBD2 systems are now more standardized and competent. They monitor hundreds of sensors and actuators. They let you know if a component or circuit has failed and also keep track of their operating efficiency. Automotive computer systems are now designed to detect malfunctions and indicate where these problems might be located. This makes finding electrical or electronic troubles much less time-consuming. The computer or electronic control unit scans input and output circuits to detect an incorrect voltage, resistance, or current. The vehicle's computer compares live readings with pre-programmed values stored in memory. When a value is out of range, the computer automatically detects the abnormal value, turns on a dash warning light, and remembers the problem location. With the engine running, electrical data is fed into the computer from all circuits critical to vehicle operation. The computer processes this data so that it can determine what outputs are needed to keep the vehicle operating at maximum efficiency. If a problem develops in a circuit, it will cause abnormally high or low electrical values to be fed into the computer. The computer will then illuminate a malfunction indicator light so that the driver will know that the car should be brought into the shop for service. With late model vehicles, a scan tool is connected to the vehicle's diagnostic connector. The scan tool then communicates with the vehicle's onboard computer to retrieve trouble codes, display circuit electrical values, run tests, and give helpful hints for finding difficult problem sources. This can all be done quickly and easily without disconnecting wires or removing parts. Earlier onboard diagnostic systems could only check a limited number of operations. Also, there was little or no standardization. A wide range of connectors, codes, and methods were used to retrieve trouble codes. This made it confusing for the technician and tool manufacturers. A serious source of air pollution is a poorly tuned or malfunctioning automobile. It consumes more fuel and can produce several times the amount of emissions. For this reason, the Environmental Protection Agency, or EPA, has passed regulations that require auto manufacturers to install standardized performance monitoring systems on their cars and light trucks. The purpose of OBD is to let you know when important mechanical and electronic parts are working abnormally, increasing air pollution and fuel consumption. Older onboard diagnostic systems simply illuminated a dash light if a sensor or circuit stopped working completely. Today's onboard diagnostic systems go a step further by monitoring how well each part of the system is operating. New vehicle diagnostics detect not just complete part failure, but parts deterioration and change in performance. OBD2 is designed to keep the vehicle running efficiently for at least 100,000 miles. A modern onboard diagnostic system detects hundreds of problems and can produce over 500 trouble codes. It checks the operating parameters of switches, sensors, actuators, their related wiring, engine efficiency, and the computer itself. One example with OBD2: engine misfire, that is, the engine not igniting and burning fuel mixture properly, will make a malfunction indicator light in the dash blink on and off. This is to warn that the misfire could overheat and damage the catalytic converter. This alerts the driver that the vehicle is being damaged and should not be driven. There are many systems that are now monitored: ignition system, fuel system, emission system, engine, electronically controlled transmission, electronic suspension control, brake system, air conditioning, airbag, other systems. A hard code or hard failure is a problem that is affecting system operation at the time of testing. An example would be a completely disconnected wire. A soft code or soft failure may not be present now, but is stored in computer memory. It might be present 1 minute and gone the next. Soft failures will usually be stored in memory for 30 to 50 engine starts. An example would be a loose terminal that connects and disconnects over bumps in the road. An operating parameter is an acceptable minimum and maximum electrical value. It might be an acceptable voltage range from the oxygen sensor, a resistance range from a temperature sensor, or an acceptable current draw from a fuel injector coil winding. In any case, the computer knows the limits for most input and output levels in its memory chips. OBD2 codes contain a letter and a 4-digit number. The first part of the code tells you which system is having trouble. The last 2 digits refer to the specific fault designation, or to which circuit or component is faulty. OBD2 trouble codes can be broken down into 4 general categories. A general circuit failure means the circuit or component has either no output or has a fixed value which is out of specs. This is the most severe and easy to locate failure. It is caused by disconnected wires, high resistance connections, shorts, or a component constantly operating out of parameter. A low input failure is one that produces a voltage, current, or signal frequency below normal operating parameters. A weak or abnormally low signal is being sent to the onboard computer. This is often caused by high circuit resistance, poor electrical connection, a contaminated or failed sensor, undercharging, or similar problems. A high input failure results when the signal reaching the onboard computer has more voltage, current, or a higher frequency than normal. This is often caused by a failure of a component, wiring problems, overcharging, or a mechanical fault. Remember that a trouble code indicates a problem with a specific circuit, but it does not tell you which part or wire in the circuit is at fault. As an example, let's say the trouble code indicated a problem with the engine temperature or coolant sensor. You would need to use basic multimeter tests to find the exact source of the problem. You might first measure the resistance of the sensor and compare it to specs for its temperature. Here, we are using special test adapters that will slide over and not damage the sensor terminals. Use a digital thermometer to measure the actual temperature of the device. Then, compare sensor resistance and sensor temperature to service manual specs to determine if the sensor is faulty. This chart shows how sensor temperature affects sensor resistance. Charts are provided to help with trouble codes. Here's a coolant sensor diagnosis chart. It gives step-by-step procedures on how to test the circuit and the sensor to find the exact source of the problem. If the sensor tests okay, you might want to check the reference voltage going to the sensor, typically a reference voltage of about 0.5 volts fed to resistance-type sensors. If reference voltage is low, check for poor electrical connections in the circuit wiring. Your service manual or scan tool will give locations of all sensors, actuators, diagnostic connectors, and other components. If you are working on an older computer-controlled vehicle, you should be familiar with the ways to activate Computer Onboard Diagnosis to pull out trouble codes without using a scan tool. With GM vehicles, connect a jumper wire or clip to ground diagnostic connector terminals. Normally, connect the jumper between terminals A and B as shown. Then turn the key on. This will make the computer spit out trouble codes by flashing the check engine light. A Morse-type on-off code is produced. If the light flashes twice, pauses, and flashes once, the code would be 21. The service manual will then explain what this code means and how to find the source of the trouble. On older Ford vehicles, the connector is usually in the engine compartment. An analog voltmeter can be used to read the trouble codes. Connect the voltmeter to the designated terminal and to the battery. The extra pigtail is jumped to another terminal to the connector. This will make the analog meter react to pulses from the onboard computer. Read the pulses at the meter just like you read the pulses at an engine indicator light. Count each needle movement, 3, a pause, and 1 needle deflections would equal code 31. On many Chrysler cars, turn the key on and off 3 times within 5 seconds and then leave the key on. This will trip self-diagnosis. A check engine light will flash in the dash showing the trouble code. The on-off pulses are read and noted so that you can refer to the service manual trouble code chart. A code 13 might indicate a problem with an injector. You would need to check the harness to the injector and the coil inside the injector itself. With several manufacturers, push 2 dash climate control buttons at the same time and read the dash display. You might have to push the warmer and off buttons at the same time. Codes will then be displayed. More information can sometimes be pulled out by pressing other buttons on the climate control. Some foreign cars use small light-emitting diodes on the side of the ECU to produce the trouble code. Always refer to the service manual for detailed instructions for using onboard diagnostics. Procedures vary even with OBD2 standardization. In ending, remember, many problems that affect a computer system are conventional: loose wire, corroded electrical connection, leaking vacuum hose, fouled spark plug, or burned engine valve. For this reason, always check for the most common types of problems before analyzing more complex computer-controlled components.